Bro, I can't get my brain out of spring break mode, god dang it, dude. Bro, I'm gonna be completely honest with you. The main reason I'm doing so many live solves, like, after the Olympiads have happened is because I haven't really got time to get my stuff together, and I have, like, a ton of competitions now, so I'm trying to get there, okay? Once I get my stuff together, I will try to make some more, like, tips videos and that kind of stuff, because I know you guys like that. But for now, we're just gonna stick with the live solves, okay? Hello everybody, I'm Carr, and today we are going to be doing the problems 21 to 25 of the AMC 12B of this year. It'll be very epic. I haven't actually tried these problems before, like the only one that I actually solved on the test was problem 22, so it should be a fun live solve. But before we get into the actual problem solving, I just wanted to give you guys the plans for like future videos once I get to like the non-live solve stuff. So I was looking at the suggestions you guys left in the forum, and basically some ideas I might have is like maybe like show you guys some of my college essays, maybe like do a day in my life, you know. A lot of you guys asked for like my life philosophy, like how I stay motivated, how do you deal with like burnout and that kind of stuff. Another of you guys had a really good idea, which was like doing the advanced C++ concepts, like you know type defs, comparators, like all the fancy C++ stuff that can make your coding faster. Maybe do like a college app talk with my friends. They're all seniors, you know what I'm saying. And maybe even some math crash course or tips videos, because a bunch of you guys wanted me to make an update on my previous video, so we'll see about that. But enough ranting, let's get on with the problem solving. Will be very cool. Alright, so problem 21, let S be the sum of all positive real numbers x, for which x to the 2 to the root 2 is equal to root 2 to the 2 to the x. So, which of the following statements is true? Basically I saw this on the test, and I was like, no, let's just skip it. I'm not even going to think about it, because, like, I don't know how to do these kind of problems, so I just skipped it. But let us see if we actually try and can actually solve this. Alright. So, whenever you have exponents, like, the first thing I try is taking the log of it both sides, but I don't know if that's going to work this time, but let's just see. 2 to the root 2 log x is equal to 2 to the x log root 2. Okay, so if we like divide, why don't we bring the logs to one side? We got like log root 2 of like, I don't know, or why don't we take the log root 2, oh yeah, same thing. So log root 2 of x is equal to 2x minus root 2, right, if we divide that over here. So now what do? Can we take the log again, and then maybe we'll get something? Log, well actually, okay, so if you have log of 2 to the 1/2, that's the same thing as taking the log 2 of x squared, right? Right? Yeah, okay. And then this is equal to 2x minus root 2. Oh, so this is the same as like 2 log 2 of x. Okay, seems legit. So if we divide by 2 on the other side, then we basically get like log 2 of x is equal to 2 to the x minus root 2, or sorry, minus root 2 minus 1. Once we take the log again, let's see, maybe you get like log 2 of x is equal to x minus like root 2 minus 1. Is that good? I don't think that's good. Well, okay, we can also write this as like x is equal to 2 to the 2 to the x minus root 2 minus 1. So x is positive. So x is positive, which doesn't mean anything, right? So, wait, okay, can we logic this? So let's say it is greater than, let's say that it is less than root 2, right? Then this is going to be very negative. It's like less than 1/2, which means that it has to be less than root 2, right? So that seems fine. Is there any reason why that would not work? So this is like 2 to the negative, like some negative number. Let's see. So it would be like a straight line and then an exponential function, which basically has at x is equal to root 2 minus 1, you basically have 2 to the 1, which is 2. So at root 2 minus 1, 1. Or sorry, root 2 minus 1, 2. No, root 2 plus 1, 2. So that is slightly below the line, right? Yeah, because if you have root 2 plus 1, that is greater than 2, so it is under y equals x. And then essentially you have an exponential function, so there should be an x. Oh, wait, what? No, that's not right. Is it right? So an exponential function should look something like this, right? And this can never be negative if x is, wait, what? How does that even work? So this is always going to be positive, right? So it's 2 to the positive some power. How does a double exponential even look? If we figure out how a double exponential looks, then we could figure this out. Okay, let's just try 2 to the 2 to the x, right? And then we can like shift it as necessary. So 2 to the 2 to the x, so like x equals 0, this is like 2 to the 1, so it's 0, 2, right? Then at x is equal to 1, then it's 4. X is equal to negative 1, then, oh, it's like getting smaller. Oh, so it basically approaches an asymptote of like 1, right? Because essentially this could become like really close to 0, but not quite. So yeah, it's like going like that. Okay. So this basically shifts it over right a little bit. So essentially you have like that, you have your y is equal to x, you have your point at 2 √2 plus 1 and 2, and then essentially there's an asymptote here, and essentially it goes like that, right? So that doesn't help, right? Because essentially you know there is 1 over here, and then we know that there is another here, but we don't know anything about the sum, right? Why don't we shifted it over, right? So we could say 2 to the 2 to like a is equal to like, I don't know, x is equal to a plus √2 plus 1, right? Still doesn't help. I don't get how. What? Huh. Well, essentially we know that there's like 1 comma 1, right? So one x is at least 1, right? And the other x is at least √2 plus 1. So it is either d or e, right? But which one is it? Okay, I guess we could just plug in stuff, right? So if we do like, wait, no. Wait, what? Okay, so this is like, yeah, that makes sense, right? So that's approximately going to be x is equal to 1 or above that, right? And then this one, if we try to find something here, why don't we do like √2 plus 1 plus like, I don't know, 2, right? Then this is going to be 2 to the 4, which is 16, which is for sure bigger, right? So it's for sure less than this. What about plus 1? Oh, wait, so if it's less than that, that means it has to be D, right? Because we know that this one's at least 1, right? And we know that this one is at least √2 plus 1, so it's at least 2, but it is less than like 3, or sorry, less than 4. So it should be D. Let's do that. Alright, nice. Wait, that actually, oh, they're not even that bad. Oh, you did that logic it. Oh, it's not, you don't actually have to find the numbers. Bruh, that makes so much more sense. Okay, that's pretty good. I see. That's cool. I love graphing problems. Okay, I do not love graphing problems, but that was a cool question, I must say. Alright, so number 22 I already know how to do. It's not a live solve. So basically the idea is like, if the board is symmetric, right? If you have like 1 comma 2, 1 comma 2, right? Then like the second person is guaranteed to win, right? Because no matter what move the first guy makes, the second guy is always going to be able to make the same move, right? So if I take 1 here, the second guy takes the 1 there. If I take 1 from this guy, the other guy takes 1 from there, right? So no matter what, the first guy is screwed. And we basically want Bet to win, right? So we want Bet to be able to make a move, or we basically want Arjun to not be able to win, right? So let's see. So uh essentially we need a way for like Beth to make a win for herself. Well, let's see. So so Arjun's goal in order to make himself win is to make the board symmetric after he's done, right? So like if he takes 6-1-1, right? Or what's a better example? Yeah, so if he takes out 2 from the 6 and you're left with like 2-2-1-1, then Arjun wins, right? Because he's the second player after he makes the first move. Because then Beth has to take 1, he could take whatever Beth takes. Okay, so 6-1-1 is not the answer, right? Then 6-2-1, like you could try, but there's no like way to make it symmetrical, right? Because you would have to break this up into like a 1 and a 2, which is not possible because you can only take 1 or 2. But let's just make sure we can eliminate the rest of them. So for 6-2-2, right? You could just convert this to 2-2, split 6 into 2-2, and that's symmetric. You could split 6 into 3-1, right? Like if you have 6 here, right? 1, 2, 3, 4, 5. Okay, yeah. So you have 6, right? So you could just take out these two, right? And you're left with 3-1. So it's 3-1, 3-1. That doesn't work. And if you wanted to make it into 3-2, you could just do like that, right? And then it's 3-2, 3-2, and then Arjun wins. So the only one that Arjun doesn't have a guaranteed way of winning is by doing 6-1. So like if you try out 6-1 and you try all the possibilities, then it's guaranteed that like Beth will have a way of making it symmetric eventually. Okay. Problem number 23. 3 balls are ordered randomly and independently tossed into bins numbered with the positive integers so that for each ball, the probability that it is tossed in a bin I is 2 to the negative I. Okay. More than 1 ball is allowed in each bin. The probability of the balls end up evenly spaced in distinct bins. Okay, 3 are evenly spaced into distinct bins. Oh, okay, I see. So 3, 17, 10 mean there's a difference of 7 between each one. That makes sense. I guess we could do casework on the distance, right? So let's just say like the distance is 1, right? Then you could do 1, 2, 3, which has a probability of like um 2 to the negative 1. So it would be like 1/2 times 1/2 times 1/4 times 1/8, right? That is for the first 3, right? Or actually, it doesn't matter. 3 balls are randomly and independently. Yeah, so it doesn't matter what order it is. So it's just like 6 factorial, right? Okay, so yeah, so 6 oh sorry, no, not 6 factorial, it's 6, because 3 factorial. And then if you want 2, 3, 4, it's 1/4 times 1/8 times 1/16. Then it becomes the 1/8 times 1/16 times 1/32. Okay, so basically this is like a geometric series with common term 1/8, right? I mean, sorry, common ratio 1/8. So it's like 6/32, 6/64 over 1 minus 1/8 is equal to like what? So 6/56 is equal to 3/28. Okay. All right. So the first case is 3/28. Then we could look at 2. That's just gonna be like 1/4 times 1 1/16 times 1/64, right? And then the same concept, right? It'll be 1/8 times 132. Wait, sorry, what? No. The first one is 1/2, so it should be 1/2, 1/8, 132, then 1/4, 1/16, 164. What's the common ratio? So each thing gets divided by 2, right? So yeah, the common ratio is the 1/8 again. So it's once again like 6 over this thing, which is what? Well, 8 times 32 is 256, so it's 3/256 over 1 minus 1/8. So that's just going to be, what's 256 over 1/8? Ah, I hate power of the 10, god dang it. So 2 to the 8 to the 5, so 32. Alright, so 32 times 7. 3/32 times 7 is 210. 210, 224. Okay, that makes sense. And I'm assuming the ratio is just going to keep getting bigger, right? So the ratio will always stay the same. This stays the same. But this basically goes 1/2, 1/4, 1/16. Then you divide this by 2, you divide that by 4. Divide this by another 2, you divide that by another 4. So the ratio of the first term is also 1/8, right? So if you multiply this by 8, you also get 224. Okay, so essentially your first term is 3/28. Your common ratio is 1/8. So you get 3/28. So what? So 3 times 8 over 28 times 7 is, so this cancels out. That's a 2. That's 7. 6/49. All right. So that gives you an answer of 55, which is A. Is that right? Very hot stuff. Epic. Hey, nice, a geo problem, let's go. So, ABCD is a parallelogram with area 15, points PQ are projections of A and C respectively onto the line BD. And points RS are projections of B and D, okay, blah blah. Okay, so I mean, you didn't have to read that, we just look at the diagram. So, suppose, wait, are these on the same line? Wait, what? So, B on AC, right? Yeah, okay, yeah. Suppose PQ is 6, RS is 8, and let D denote the length of BD, longer diagonal. This seems not bad, right? Can't be that bad. Okay, so we want to find this length, right? Seems like a bunch of similar triangles, like this is similar to that. Okay, well, we know that, wait, do they bisect each other? Yeah, they should. Yeah, so this has length 4, this has length PQ, what? This is length 3, right? So that, I mean, sorry, what? RS. So this has length 4, this has length 3. Oh, and the area is 15. Okay, so let's see what we could do for the area, right? So area is equal to AC. Okay, so area is AC times DS, right? Because, yeah, that should be right, is equal to 15, but we don't know DS, right? Or AC. So we only know RS, but we don't know the height. Okay, we also know PQ. What does knowing PQ help? So this is 3. Oh, they're similar. Okay. So we know this is 3, but we don't know any other side lengths though. That's annoying. Well, we know the ratio of like this thing to this thing is 3 to 4. Or 4 to 3. Okay, let's see. Okay, let's just draw the diagram for. Okay, let's copy in the diagram because I do not want to draw that nasty thing. I will fail miserably if I try that. Okay, there we go. We got that. Very cool. Alright, so we got this tiny diagram. Okay, so we know that this is 3, this is 4, this whole thing is 4, right? We don't know anything else, right? Well, we know the area. What can we say about the area? So this thing, oh yeah, what can we even say about the area? Well, we know that theta. No, we don't even know anything about that angle either, right? or we know the area. Well, okay, so let's just say, let's try. Okay, so we need to find the area in terms of some of the known side lengths, right? So, okay, let's just say this is like x, right? The x. So we know that like 3 over x is equal to, if we say this thing is d over 2, right? D over 2, then, or let's just call it d, and we can multiply by, or divide by 2 at, no, what? Multiply by 2 at the end, so this part is d. Hopefully you don't troll at the very end, but hopefully we'll remember, is equal to, so 3 over x, so is equal to 4 over d, right? So essentially this length over here is going to be like 4/3 d, right? Sorry, wait, what? No. 3/4 d, okay. Oh, maybe I should have put that on a different layer, hold up. Okay, so essentially we have this 3, this is 4, this is 3/4 d, right? And then this thing is d. Then essentially, now we could find the area, right? So the area is equal to 6/4 d times that, which is equal to d. Okay, so the height is equal to root d squared minus 4 squared, so minus 16. That's the height. And then we want to multiply by this length, which is 3/2 d. And that's the area, that's equal to 15. So if we just solve this, we should be good, right? Right? I think we should be good. Although that's a quartic, right? Well, no, it's like a quadratic in d squared, so it should be fine. So we go d squared minus 16 times 9 over 4 d squared is equal to 225. And we could just like replace d, we're even solving for d squared, so that works too. So we could say like 9/4 x squared minus 16, well 16, oh wait, what? So not, okay, so 36 x is equal to 225, where x is equal to d squared. And then essentially we could just use quadratic formula like cool kids, right? Oh, let's first divide by 9, because that's cool. Divide by 9, multiply by 4, so x squared minus 16x, 25, right? So minus, what? 100 minus 100 is equal to 0. And this is just the same thing as what is the factor? Okay, I guess we had a quadratic formula of this boy, so plus or minus root 256 minus, or plus 4 times 100 over 2. So that is just equal to 8 plus or minus root. The 256 divided by 4 is what? 64, and then plus 100. So 8 plus or minus root 164 is, if we divide this by 4, we basically get 25 plus 16, 41. 41 times 4. So 8 plus 2 root 41. And then we gotta remember to multiply by 2. Very good. I almost forgot it. If not with an answer there, I would have got wrecked, but it wasn't, so we're chilling. Alright. Okay, so, well, we're still not chilling. What the heck? No, that's not right. Did I do something wrong? Okay, so we divide by 9, that gives you 25 times 4. Okay, that's right. Divide by 4 times 9. Well, okay, you got 16, that's right. And then, oh, you had to multiply by 4. Oh, that makes so much more sense. Okay, so we had like 16 plus, yeah, because it's d squared. Oh my god, that makes so much more sense. Okay, so you multiply this by 2 again, right? And then you get 32 plus 8 root 41. Okay, so that makes a bit more sense. 81 should be our answer. A, again, very cool. Hey, very nice. I love Geo. Geo is very cool. Alright, number 25. Okay, there is no guarantee we're solving this one, boys. Alright, so let S, oh, I hate lattice points. Okay, in the coordinate plane. I know it's technically geo, but lattice points are just nasty. Both of whose coordinates are between 1 and 30, exactly 300 points in S, lie on or below a line with equation y is equal to mx, right? So, possible values of m lie in an interval where, okay. There was an equation for this, such an easy equation. It was like, the number of things it goes through is like m plus n minus that. Okay, so I guess we start with this, right? And then, oh, but no, that's only if it goes like all the way to the top, right? Okay, so 300 points. So there's 900 points in 1 to 30. Oh, wait, no, okay, so it is like, okay, so the line starts here, right? And then it goes into 1 through 30. Okay. How do you even do that? Oh, it's so nasty though. God dang it. Well, okay, so it's one continuous interval, right? So at some point there's like exactly 300 blocks on or at it, and then we could keep going up until we lose one block, or no, we gain one block. So it can't. So it'll be at like the bottom of one block, and then it'll go to the top of that. No, what? It'll be at the bottom of one block? No, I don't even know. Not necessarily at the bottom of one block. Okay, so essentially the way it works is like, how do you know if it goes through a box or if it's entirely above a box? Or no, it's not even the boxes though. It's actual lattice points. Okay. Oh, wait. Okay. So essentially, if it is below or on the line, we basically have like y is less than or equal to mx, right? So we essentially want there to be like 300 points that satisfy that, and we could basically do this as like what? I guess the maximum x is 30, right? Yeah, so essentially there should be like, let's see, so at 30, let's say that x is equal to 30, then y is less than or equal to 30m. Okay, let's just say m is equal to 1, right? Then it's like 30 plus 29, so on and so forth, so 30 times 31 over 2, so that's like 31 times 15, which is equal to 515013564. Okay, so 465 if you just do like straight through the middle, which makes sense, right? There's like 31 that are in the middle. Yeah, okay, that makes sense. And then we basically want to, okay, so let's say we reduce m a little bit. Okay, so, well, I mean, basically the idea is we want to, like, if we reduce, basically it's just like 465m approximately, right? So if you do 300 over 465, then we basically get, what? So 60 over, what's 465 over 5? 31 times 3 is 93, so that's just 20 over 31. So 2/3 approximately should be right. Okay, let's see. So it is the floor of, so the number of things that fit our floor of this, right? So that means it's strictly less than like 465 now. So that means 20 over 31 is the lower bound. So it has to be at least a little bit bigger than 20 over 31. What about upper bound? Can we do upper bound somehow? Oh, we need a quick formula for figuring out how many things are less than it. Yeah, it has something to do with GCD though. I know that. Well, that was for like how many boxes it. Okay, so essentially it's like 10 plus, like, I don't know. Well, it's approximately like 10 times 9 over 2 um, times 30, right? Or times 3. 10 times 9 over 2 times 3. No, that's not right. How did it work? So, I guess if you do 2/3, right? Oh, so it's 20 at the end. So you got like 20 plus 19 plus 19. Oh, well, I guess this will be, okay, so 20 plus 19 plus 19, 19. Well, okay, so after it goes back 3 x's, it'll go down 2. Okay, so plus 19, 18, 18. Okay. Or, sorry, what? Yeah, okay, that's right. And then when it gets to 18, it repeats. So, oh, okay, so it is 1 in each thing. So you basically get like 20 plus 19 plus 18 plus 18 plus 17 plus 16, so on and so forth. So essentially the only ones that are repeated are multiples of 3. So we basically just do 20 times, I don't know, times 21. 20 times 21 over 2, so that is 210, plus 18 plus 15 all the way down to plus 3. Well, and then plus 1, I suppose, at the very end, right? What is this equal to? So that's like 3 times 9 times 10 over 2. That's not right. Oh, it's 3 times 6 times 7 over 2, which is also not right. What? Okay, this is not the right way to do it. Hold up. Okay, so how do you get one more lattice point, right? That is when your like fraction, let's say m is equal to p over q, right? When k, when like px is like greater than the next multiple of q, right? Okay, well we know it goes from like 1 to 20 somehow, right? So essentially we need like 1 plus 20. Okay, so we know that 20, like 1 to 20 gives you like 210, right? So we essentially need to add 90 somehow. Okay, yeah, so some things need to be repeated, right? Well, we don't know it even ends on 20 though. For 2/3 it crosses like every time, right? Okay, so it goes 0, doesn't cross, then cross, then back to 0, then doesn't cross. Oh, so I guess it only crosses every third, right? So this is 0, this is 1, this is 2. So from 2 to 30 is how many dudes? 29, right? So you add 29 plus like 26 plus so on and so forth, all the way to plus 1, right? Or 2. Oh, I mean, hitting a line also counts as crossing, so I guess you cross twice. Every 3? Yeah, you cross twice every 3, okay. So 2, 3, and 4. You also cross at 4, so 29 plus 27 plus 26 plus all the way over to, like, I don't know, 2 plus 0. Yeah, 2 plus 0, okay. So 27 to 0 gives you a sum of like 9 times 10 over 2 times 3, which is 135. And then 29 is just 135 plus 2 times 9, or 2 times 10. Okay, so it's 135 plus 155 gives you 290. Oh yeah, I don't know how to do this one. What the heck? Okay, let's get a hint. Okay, let's see. Okay, yeah, that's what we got. Alright. Okay, we got that. Alright, very nice. Oh, whoops. I mean, I guess 2/3 works. Okay, so I guess we just needed to make that work. Okay, so, I just did my math wrong. Okay, so 2/3 works. So 2/3 gives you exactly, oh yeah, what? Yeah, how did I don't know what I was doing. Okay, so 2/3 gives you exactly 300. Okay, then how does that help? So essentially you don't want to lose any, right? So 2. So essentially you get like, okay, let's see. So 2, you get 1 from 2, x equals 2, you get 1. And then from x equals 3, you get 2, right? And then you get 2, and then you get 3, and then you get 4. Okay, so 1, 2, right? And then 2, and then 3, and then 4, and then 4 again, and then plus 5, plus 6, and then you get a 6 again. So every other, you do something, right? Wait, no, what? So you get 1 plus 2 plus 2, right? Because once you reach a multiple of 3, you add 2. You don't add anything, then you add 1, and then you gotta add 1 immediately after. Okay, so 2 plus 2 plus 3 plus 4, and then it's 4 plus 5, 6 plus 6. Oh, I see. Okay. Oh, really? Okay. So essentially, you just get like all the way up to 20 plus 20, right? This is even numbers, right? So 20 plus 20. I don't know what. Okay, yeah, 20, just 20. Ends on 20, so you get like 20 times 19, or 20 times 21 over 2, plus 2 times, and then there's how many even numbers from 2 to 18, right? So 9 times 10 over 2. That gives you, okay, so this, yeah, okay, that's why it's 300. Okay. So essentially, we want to keep these numbers, right? We don't want to change anything. So essentially, we want to not go over any more lattice points. So where is the closest lattice point to 2/3? 3, 2, all right, like that. 3, 2. So you got like that, all right. So which lattice point is closest to the line? Is it this guy or is it that guy? Okay, so this distance is like 1 or 2/3, right? This distance is only 1/3, so this guy is going to be closer, right? So essentially you have like, okay, so essentially you want to go through this lattice point, right? And then, well, actually no, but then it might, later it'll snowball out of control. Oh, okay, so I guess you got it, the last one is the last, like the very, very last one where it does that. Okay, so on the very last one you're at 20, right? Going like this, and you want to change M to see that it doesn't hit any of the previous lines. I mean the next lattice points. Okay. So the way you would do that is, maybe it'll go through this one. Let's try and see if that slope is less. So that would be 29 comma 20, right? So yeah, so the slope is just like literally 29 over 20. Or it could go through this other closer one, which is down 1 over 2, which is what? 28 comma 19. So which one is bigger, 28 over 19 or 29 over 20? We could just subtract them, but there's probably an easy formula for this. 560 minus 29 times 19. 1862092 1515. 550. 560 minus 551. So this is bigger, and we want the smaller one. So 29 over 20. So 29 over 20 minus 2 over 3 gives you 87 minus 40 over 60 is equal to 37 over 60, which is not right. No, sorry, 47 over 6, which is not right. Hold up. 29 over 20. Well, basically we want the lattice point that's above this that is the closest to the line, right? Or the last point above it that has the least slope. I guess you could do like 30 over 21, technically. It's 30 over 21, smaller. Let's test that. So 29 over 20 minus 30 over 21. So you multiply, okay, so this is the same as 10 over 7. So 140, 63, 203 minus 10, minus 200. Oh, so it is smaller. Okay, so this lattice point is the one that we should be scared about. Okay, alright. So then we basically have 10 over 7 minus 2/3 gives you 30 minus 14 is 16 over 21, which is also not right. Wait, what? Hold up. Okay, so some lattice point over here, right? One of the lattice points. I'm doing it backwards, dude. It is 21 over. Oh, okay, yeah, okay. So I guess 19 over 28 is the one that's the smallest. Okay, 19 over 28. That makes sense. So 19 over 28 minus 2/3, but that's gonna be way bigger, right? I guess not. 57 minus 56 over 28 times 3 is equal to 1 over 60 plus 24. 1 over 84. Oh, so it's 85. Yes, let's go. Let's go, finally, dude. Oh, bruh. I probably wouldn't have needed the hint if I actually calculated it right, but yeah, okay, so 2/3 works, that makes it a lot easier, and then we got it. Okay, so it is 85, very nice. Alright, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. I hope it was helpful, but I will get to the actual non-Livesolve stuff soon, so stay posted. If you guys have any suggestions, let me know in the comments, but other than that, thank you guys so much for watching again, and see you guys next time.